don't see Lucas or Ivan.
Ivan says, I'm currently trying to join, but it's asking me to sign in.
Shouldn't have to sign in. You don't have to sign in, do you?
No.
Well, I'll record it for him anyway. All right. Well, hi, everybody. Miss you guys. Nice to see your faces. Nice job last week. I have everybody's quizzes came in eventually. Hey, there's Ivan. Did you have to sign in, Ivan, or are you okay? Okay, whatever.
Great answer.
A couple of you are still, we're talking about homework. I think, I talked to Dame, I think Lucas is the only one that has to turn in homework still. So just to be clear, I would like to see homework every week. And if you can just, the best thing to do is if you can just take pictures of everything into one document and then upload the one document with maybe, I don't know, 10, 15 pages in it. That's awesome. I just go check, just easier to check them off. I'm going to talk to you about things and message to talk about with other students, but we're in the middle. The meeting I left actually to come here was about what are we going to do about fourth quarter grades and credits. And I can't say this is exactly what it's going to be, but we'll probably end up giving you the option of how you want to get credits for fourth quarter. This is high school credits now. College credits, a whole different story. But the high school credits, we'll make a couple different options available. So for now, I hope you just keep going. I have got everything to put in the grade book. I'll probably keep your grade book up to date. I'm not sure that I'm going to keep all my other classes up to date because I'm not really sure exactly what I'm going to do with all that. But I think I'm just going to keep you rolling because part of the work you're doing now is part of your college grade anyway. So that should work. And I don't know how are your other college classes going through school?
All right.
They're fine.
That chemistry class got to be a bear. Our teacher's probably driving you crazy.
Oh my God, tell me about it.
All right, I don't want to waste too much more time. So what I have up on the screen, I hope you can see, is the quiz. Can you see the quiz?
Yes.
Is there any part of this quiz you want me to go over? I've gone over with you individually via email. For the most part, I thought things were pretty good. Some of you ended up at a sort of a funky place on one of those tangent problems on page 2. Specifically 6C, I think we kind of got some weird results there. But this is sort of your call. I sort of gave you feedback individually. My question is, do you want me to go in detail about any of this, or was what I explained good enough in the email?
Time was good.
Okay. Anybody else want to hear something about the quiz? Okay.
Your
If you
email was good.
do, what's that?
Your email was good.
Okay, all right.
Yeah.
Well, if you do, and I don't explain things well enough in the email, let me know. I'll walk you through all that. This is not supposed to be some big secret where you have to guess at what went wrong. So that's that. Aiden, I'm not to put you on the spot here, Aiden, but I'm going to ask or mentioned that these problems here on the worksheet from Friday were a little confuzzling. And these are the last half of the worksheet, the CUDA worksheet that you did solving equations. And so I promised him, but I'll include that to all of you, that I can go over some of these questions if you'd like. And in that spirit, I will open up this time right now to go over any questions you have from the homework from last week that may have come up. But I want to particularly look at these ones right here. And Aiden, I want you to pick a couple of these that I'll actually transfer onto the whiteboard and walk you through the process. Because a lot of these end up being similar. So I can mention some similarities between them. For example, 9, 10, 11, and 12 are all the same basic type of problem. Let me just mention that. On those problems, they're all just quadratic problems with sine theta. So for 9 and 10, we have a quadratic already written. if you want to replace sine theta with x, that's fine. You have to eventually solve for sine theta. 11 and 12 have got sine and cosine squared, but we know from the Pythagorean identity we can replace cosine squared with 1 minus sine squared. And so you can turn all of these, 9, 10, 11, 12, all turn into quadratic equations with sine squared. Okay, so that's those taken care of. I'm curious about like 7 or 8. 13 is kind of a special one. So 7, 8, and 14 are fairly similar. I want to know if you have any issues with that.
Can we just do 7?
7?
Mm-hmm.
Sure. You picked the hardest one. Nice work. Okay, I'm going to switch to the whiteboard. So you'll lose the problem, but I'll write it up here as soon as I find it again. So 7 says the square root of 2 cotangent theta minus 3 secant theta equals cotangent theta secant theta minus 3 secant theta. Good? So here's a couple things I noticed first of all. For starters, I don't love having cotangents and secants. In the back of my mind, I'm thinking cotangent, though, is cosine over sine. I'm using bad notation here, but you get the idea. And secant is 1 over cosine. So I look at this right here, and I think, that's interesting to me, because I feel like some things will cancel out on that. Let me get you guys back up a second. But here's the thing that I find most interesting about this problem. Look here, and look here. Notice anything?
They cancel out.
We'll cancel
Yeah.
out if you want.
Yeah, they cancel out. So this problem now is going to become much simpler. Cotangent theta is cosine theta over sine theta. And secant's 1 over cosine theta. So these are going to cancel. So the whole right side of the problem is really just 1 over sine theta. And I'm going to leave it as 1 over sine theta, even though I could write it as secant theta, because I feel like I'm going to want to simplify this down to a cosine or a sine problem. So now let's take this one and write it as square root 2. Cotangent is cosine theta over sine theta, right? Well, now you might notice that I could technically multiply both sides by sine theta, or I could just cross them out. So if I multiply by sine theta, both sides, now I'm crossing them out. End up with square root 2 cosine theta equals 1. So cosine theta equals 1 over square root 2, whoops, which is root 2 over 2. And now from there, we find the answers. I'll go back to the screen because I want to point something out here that you may have not have picked up on, and that is that these questions ask you to solve for 0 to 2 pi. But I want you to pay real close attention. This is actually a really common thing that we run into when we start solving equations. You'll see that theta can equal 0, but not 2 pi. If you think about that, it makes sense, because once I get around to 2 pi, I'm basically back to 0 again. So if 0 is an answer, then I'm duplicating myself at 2 pi. And so for number 7, where we had cosine theta equals root 2 over 2, that should be pi over 4 and 7 pi over 4 within the first time around the circle. And sure enough, we see 7 is pi over 4 and 7 pi over 4. We didn't have to do the plus 2 pi n or 2 pi k on these problems because this particular worksheet just said stop at 2 pi. In reality, like you did on your quiz, very nicely, we have to include the periods in all the answers because the question will usually ask for all the solutions, not just a limited. Does that help a little bit, Aiden?
Yep, thank you.
Okay, any other of these that any of you want to see? Oh, let's talk about 13 real quick, okay? Let me go to 13. 13 was kind of funky. Did any of you, I'll give you a chance to look at 13. It's minus cosine plus sine equals 1. Did anybody sort of have a special approach to that? Anything come to mind as you were tackling this one? Okay, I'll take that as a no. Fair enough. What I would do here is I'd write it as sine theta minus cosine theta equals 1. And then I just use my brain. Now I know that looks like it's the beginning of a difference of squares problem, but it's really not going to accomplish a whole lot for us at this point. But think about this. What are some possible values for sine and cosine that if you subtracted, you get 1? Remember that sine and cosine never get bigger than 1. So the first thing that jumps into mind is 1 minus 0 equals 1. That has to be one of the solutions. I can't have like 1.5 minus 1/2 because sine can't equal 1.5. The biggest sine can be is 1, so the only way this works is if cosine is 0. So where on the circle does sine equal 1 and cosine equal 0? Who knows?
I/2.
Right. 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 So the solution to this part of the problem is pi/2. Right. Now there's another option, and that is if sine is 0. Cosine would have to be real careful here, to equal +1, cosine would have to be -1, wouldn't it? Would that still work to get us a +1? So where is sine 0 and cosine -1?
Pi.
Right there, pi. So there's no fancy identities to use here. For 13, we just get pi/2 and pi. It's one of those little special cases we run into that it's kind of fun, but a little stressful too. Anything else on homework that you want to go over? I got my book here. We can look at specific problems, or we can dive into new identities today. Sounds like we're going to dive. That sound good? Let's dive. What I would like you to have, and I don't have it super handy, but I can probably find it, is this identity sheet right here. The sum and difference identities. If you don't have it, I'll develop all these for you today, but that's what we're going to use as our reference. And really, this is going to begin what's going to end up being a 7-day process, maybe, to excuse me, to explore this big, vast world of trig identities. And I think I gave all the handouts to you, but they're a little bit daunting. I remember your looks in your eyes, like when you gave them, like, are you kidding me? What are we doing? But we're just going to take these one day at a time. Remember, I'm going to break the next section into 5 days. So we're just going to take off a little bit at a time. And I just want to tell you, in a previous school where I taught, we used to require our trig students to memorize there's about 20 different identities. They had to memorize them all. And we gave them tests. And you had to get 100% on the test, or you would get a 0 and have to retake it. And the second time, you'd have to get a 90, or you get a 0, and so on. And it was really, really tough. And I'm not going to do that to you now. I thought about it, but of course, with this going on, we're not going to do that. But the sooner you can reach a point where you, if not memorize these, at least recognize them and have a pretty good idea of what they look like, the easier life is going to get for you. So I'm not going to require you to memorize. In theory, a lot of these, once you get started, you'll be able to derive on your own, but it takes some doing, and it's daunting. Like today, I'm going to give you 6 identities. And you're like, how are we gonna do 6 identities? Well, they're all gonna be, there's a pattern to them. And I want you to remember the pattern. And then once you get the pattern down, then you'll maybe remember them a little bit easier. So let me start with a couple of concepts here. We are doing, and let me just put it in the right, make sure you get the right form. I gave you A and B. Just give me 1 second. I want to check and see how your book does it, because I'll use whatever variables, I don't know, you probably don't remember either. I'll use whatever variables your book uses. Your book is using U and V. So what would you rather have? You tell me, A and B like the handout I gave you, or U and V like the book?
A and B.
What's that, A and B?
Yes.
Okay, A and B, cool. So we're looking at dealing with A plus B and A minus B, okay? These are called the sum and difference identities. So we're gonna be dealing with sine, cosine, and tangent of these identities. That's the 6 identities. 3 ratios, 2 different cases, plus and minus. And to get you in the mindset, I'm going to give you some structure to work with. Sine goes sine, cosine, cosine, sine. We'll work with this, we'll play with this, but I want you to remember this. Cosine is cosine, cosine, sine, sine. So I don't know how you want to think about that, but you know, sine, you one of each, and then cosine does two at a time. Now you may not know what this means yet, but I want you to get this in your mindset now. The last thing I want to give you is a little mnemonic. You know, anybody know what that word is? It's an SAT word, mnemonic. Spelled with an M. Anyone? No? No?
How can you remember things?
Okay, we won't do SAT then. SAT's canceled. This is a way to remember what the rules are. So here's going to be your first rule. Sine stays the same. That may not make a lot of sense to you, but it will in just a minute. Sine stays the same, and I'll come back to that in just a second, okay? Let's take a look at the first one. So the sign of the sum identities, we're talking about sine of A plus B, deals with finding the sine of angle A and the sine of angle B. And I understand if at this point you have no idea why this is useful, and I appreciate that, and I will tell you when we get done with this. But right now we're just learning a bunch of stuff, okay? So remember I said before, sine, cosine, cosine, sine. So I'm going to write sine A, cosine B, cosine A, sine B. Okay, so we're switching sine A, cosine B, and cosine sine. And then our rule is sine stays the same. You can almost write it as SIGN, the sign stays the same. If that's plus, that's plus. That's it. Sine, cosine, cosine, sine. A and B in order, sign stays the same. And that means that the sign of A minus B looks the same. It's sine A, cosine B, cosine A, sine B, but sine stays the same. So if you look at your identity sheet, you should see, in fact, that sine stays the same. Sine A, cosine B, cosine A, sine B with a plus and minus in between. Now, I think what I'm going to do is I'm going to give you a problem right now. I wasn't going to do this, but I'm just living on the edge right now. Give you a problem of why you might want to do this. Ready? I'd like you to find the sine 7 pi over 12 without a calculator. And your first thought should be, I can't do that. Because 7 pi over 12 is not one of my special angles. I get pi over 6s, pi over 4s, pi over 3s. I got all that. I don't know how to do 7 pi over 12. So I will pose to you, how can we use either of these to get to 7 pi over 12? Can you write this as the sine of two angles added together? Or can you write this as the sine, I'm going to give you a challenge here, of two angles subtracted? Ready, go. Who knows one?
I over 4.
Pi over 4. Where do you want to put that, in the plus or the minus?
The plus.
Pi over 4. And Monse, is that you?
Sure.
Was that you or was that you, Anna? I didn't see it was Anna. Was that you? Oh, you guys are frustrated.
That was me. That was me.
Okay. So pi over 4, Anna, I'm going to write as 3 pi over 12, just in the back of my mind. Because if I know pi over 4 as 3 pi over 12, I know what I have to add to it over here to get 7 pi over 12. What is it?
Pi over 3.
Are you like doing a ventriloquist now? You guys are, all right. It's going to be 4 pi over 12 that I have to add to make 7 pi over 12, which is pi over 3. And those are angles we know. So some of you are going to have a chance to do that. I want to hear about a subtraction problem, though. What are some angles we could use where you subtract? So now we got to start with an angle bigger than 7 pi over 12, but it has to be one that we know. And think about things over 12.
8 pi over 12.
So 8 pi over 12 I like, but I kind of don't like. And I'll tell you why I don't like 8 pi over 12. We'll try it here. If I start with 8 pi over 12, what do I have to subtract to get to 7 pi over 12?
Pi over 12.
1 pi over 12, right? But the problem is, while I know this angle, I don't know that angle. So I like the idea, but I want to pick now angles that I know. I'll start you off. How about 10 pi over 12? Isn't that 5 pi over 6? And then what do I subtract from there? Sorry, I heard but can you see what I'm doing? What do you think about that? Can you live with those? It's not the only way to do it, but it's certainly a possibility. All right. What I'd like you to do is, if you are a male, I'd like you to do the subtraction problem. If you're female, do the addition problem. See what we get for 7 pi over 12. Using the identity, it's on the screen. And I am a male, so I will do it that way, and then one of you girls can tell me what we're going to do.
What are we doing?
You're evaluating this. Female. We're really doing this, Anna. But you're going to do it this way. Guys, you're going to do it that way. Sorry that it's sloppy writing. Do you see what I wrote there for what I did? Sine A cosine B minus cosine A sine B. That's my answer.
I got the same thing, but I don't think there's a negative, if that's a negative.
Wait, you got the same thing or not?
Yeah, I did.
It should be the same thing.
It shouldn't?
It should.
That's what I got.
Well, then you did it right.
Okay.
Okay. But you got it a different way, I assume, right?
Yeah, I did.
So let me just, once it's sine 7 pi over 4 cosine pi, oh, sorry, not 7 pi over 4. Sorry, I read something wrong. This is just pi. Cosine pi over 3 plus,
sine pi over 4. And then sine pi over 3.
does that look right?
Yes.
Sine pi over 4 is root 2 over 2, right?
Yeah.
And
Times.
cosine pi over 3 is 1/2.
Yes. And
Plus.
then the root 2 over 2.
And
Times root 3 over 2.
which is root 2 over 4 plus root 6 over 4.
Yeah.
Yeah, it has to work out. My point is, there's two ways to do all these problems. And what you're going to do is you're going to eventually develop confidence with addition or subtraction. Whatever numbers jump into your head most quickly will be what you end up doing. Any questions about sine? Because we have two more to go through, cosine and tangent here. Can we move on? I'll take that as a yes. Okay. Remember a while back, or ways back, I mentioned cosine would go as cosine, cosine, sine, sine. So we're going to remember that, but there's a new mnemonic we're going to use. So back here again, I said sine stays the same. Cosine changes. What do you think? Sine stays the same. Cosine changes. Which means, yeah, you're laughing, but you're going to remember this. Which means that when we, for example, we have cosine of A plus B, the sign's going to change with all the minus here. This will equal cosine A, cosine B, minus sine A, sine B. The sign changes. Cosine changes. So cosine of A minus B is cosine A, cosine B, plus sine A, sine B. And that's what we get right here. Put this up here, and you can see these nice little identities. Cosine, plus goes to minus, minus goes to plus, cosine, cosine, sine, sine, and we get our second identity. So I think we should try one now. Let me pick one that is, let's do this one. This is a little bit easier. Cosine of 5 pi over 12. Make that really clear so it's not any question here. Cosine 5 pi over 12. And I want to do it two ways again. So I want you to brainstorm with me, and I want you to tell me cosine of two angles added or cosine of two angles subtracted. Ready to go. All I want you to do is pick the angles for now.
Pi over 6.
Pi over 6 I heard, which in my mind I'm changing to 2 pi over 12. Okay? So I've got, what's the other one?
Pi over 4.
2 pi over 12 plus 3 pi over 12 makes Yeah, I like it. I think that's about the only thing you could do. I mean, in theory, you could use negative angles if you wanted to, but that works for me. How about the subtraction? Gentlemen, from whom I have not heard.
Girl power, Anna.
Oh, yeah.
What do you got? Let me hear it. Boys. How do I get two angles I subtract to make 5 pi over 12?
18 pi over 12.
18 pi over 12 is a good start. The problem with 18, though, is what do I have to subtract to get 5?
Not enough.
Well, I subtract 13. I don't know 13. So I've got to start with something over 12 where I can subtract something I know and get 5. I think of 2 right off the top of my head. It's killing you, isn't it, Anna?
Pi over
Yeah.
Killing you. Boys, help us out.
20 pi over 12.
What?
20 pi over 12.
20 pi over 12?
Yep.
All right, rock and roll. We'll do it. Definitely not the one I was thinking, but we'll do it. 20 pi over 12 minus 15 pi over 12? Okay. So what does this reduce to?
10 over 6.
I think it's 5 pi over 3, isn't it?
Oh, getting there.
And what's this? 5 pi over 4? Check my math here. How well do you know your fractions? Oh, Damien, come on. Well, apparently our fractions need a little bit of work. This is a good practice for fractions here. All right, can we live with this? So to be clear, not at all the combination I was thinking we were going to do, but it works. So we'll make it work. You know what we're going to do? Girls, you get the subtraction one now. One that Foster came up with. And guys, I want you to do the addition one that looks a whole lot easier.
Okay.
And I won't do anything quite yet. I'm gonna let you work on that for just a minute or two so you can do that without my help. Remember, cosine changes. Do cosine, cosine, sine, sine. So I'm going to turn the whiteboard off so I can write on it, but you can't see it. Then we'll turn it back on in just a second. No, I'm just kidding. Now I can't see the whiteboard. Huh, that's fun. Shoot. All right, we're back. Somebody has an answer. Go ahead and just share your final answer, and then we'll see if we agree. Also, one more thought. While you're working, remember that 5 pi over 12 is just shy of 6 pi over 12. So it's just below pi over 2. So cosine, I think, should be reasonably small, like getting close to 0. Not 0 necessarily, but it's a pretty small number because it should be almost to where cosine would be 0. Foster, I feel like you have an answer. No, just kidding. No.
I got negative square root of 2 plus square root over 4.
Say it again. Negative square root 2 plus square root 6?
Over 4.
Or negative square root 2 plus square root of 6 all over 4, which we could potentially write as square root 6 minus square root 2 over 4.
Yeah.
Okay, and you did this one, right?
The minus.
Right. Boys, what'd you come up with?
I got the second equation you wrote, the square root of 6 minus square root 2 over 4.
Okay, and did you get it, I'm just curious, in this form initially?
Yeah.
Yeah, so what you'll probably find out is based on how you approach this, you might end up with the minus and then the plus, or the plus and the minus, but it all comes out to be the same answer. Is there anybody here who's not getting square root 6 minus square root 2 all over 4? Meaning, do you want me to go through the process, or do you feel like you understand it okay? I got a whole lot more angles we can use if we need to. And I'll tell you, the pi over 12 angles are very common for this because there's so many factors of 12 that we can, we can do the pi over 3 and the pi over 4 and the pi over 6s really nicely. Pi over 8s are a little bit tougher to do, but we'll deal with pi over 8s when we get to half angles, which is going to come later in the week, because the half angle identities allow us to take half of like a pi over 4. So, are we okay on cosine? Cosine changes. Sine stays the same. Cosine changes. If that's okay, then I want to finish up with the big one, and that's tangent. This one's not super fun, but in some ways it's easier because we really define tangent as sine over cosine. Okay. So bear with me while I walk through the derivation here. Okay, this is going to be a little bit lengthy, but it's kind of cool how it works out. I know that sine of A plus B is sine A, cosine B, sine stays the same, cosine A, sine B. And I'm going to draw the fraction bar here somewhat mysteriously, because you're thinking, why did he leave so much room between that expression and the fraction bar? That's a really good question, and I hope I have an answer for that soon. Cosine A plus B, cosine A, cosine B, cosine changes over sine A, sine B. I want you to look real carefully at your identity sheet, this one right here. You're going to notice that a couple things happen with tangent. First of all, it doesn't look anything like the sine or cosine ones, except that it's written in fraction form, which is what we have on the screen, but it doesn't look anything like that. So here's where we use a little bit of trickeration. I'm going to divide, how do I say this? I'm going to divide everything by the same thing. So I'm going to multiply by 1 over cosine A, cosine B over 1 over cosine A, cosine B. That's what I'm going to do here. Okay, so to be clear, I'm not doing any sort of property of equality. I'm simply multiplying this fraction by something divided by itself. This whole thing equals 1. Now, what it looks like when I do it's going to look very different, but that's what I'm going to do. So here's what we're going to have. I'm going to have cosine A, cosine B there, cosine A, cosine B there, cosine A, cosine B there, cosine A, cosine B there. Let me erase all of this. Okay, so I'm going to pause there for a second and let you ponder what you see. I wrote tangent as a ratio of sine over cosine. That's it. And then, for reasons that are not clear to you yet, but will become very clear very quickly, I divided everything by cosine A, cosine B. That is, I multiplied the top and bottom both by 1 over cosine A, cosine B. Excuse me, that term gets distributed through, and so everything gets divided by cosine A, cosine B. Is there anybody who's unhappy with where we are right now. Okay. Now I want you to watch what happens. This is where the magic happens. Cosine B, cosine B cancel. Cosine A cancel. Cosine A cancel. Cosine B cancel, leaving me with 1. And nothing cancels there. So what do I have? This is tangent A. This is tangent B. On the bottom, I have 1 minus, this is tangent A, and this is tangent B. And that's your identity. So this is where you kind of get into a bind. Do you memorize this? You can. Or if you get in a pinch, you can always derive it from sine and cosine. But a couple of things that I do notice about this I want to point out. We have sine on top, and sine stays the same, right? So in this plus problem, we end up with a plus. Frankly, because sine was on top and sine stays the same. Cosine on the bottom, cosine changes. So I bet you could probably predict what tangent of A minus B is going to equal. It's the same, let me pull it down. It's the same exact problem here. Well, I'll put it in. Same exact problem, except that we'll have a minus on top, so it's tangent A minus tangent B. Again, sine stays the same over 1 plus tan A tan B, because cosine changes. That's it for today, guys. How are we doing?
Okay.
Okay, so here's where it's going to be. You got 2 days to work on this. It's a little weird at first, and then you start trusting the process, and like, oh my gosh, this really does work. And I encourage you, when you do these problems, to work them out on your own, like you would, we're using these identities, and then check it on your calculator if you want. Remember, your calculator will give you a decimal answer, and you're going to get a, usually a radical answer, something that's fairly clean, hopefully, in your work. So you might have to do some conversion, but check them out and see if it works. I think you'll be pleasantly surprised that they come out very nicely. And shoot me a text, give me a call, email me, whatever you do if you get stuck and you're not sure exactly where to go. The next 2 days of assignments, I'll write up on the board here. 5.4a and 5.4b, they're both page 378. I don't know what I just wrote there, sorry about that. 7, 8, 13 to 16, 27 to 30, 36, 37, 53, 71, 72. That's all kinds of fun. And 9, 10, a lot of the same kind of problems. 19 through 24, 38 to 40, 55, 73, 74. Okay, so lots of good work ahead of us. This is going to be the first chance you get to really start applying some brand new identities to problems you wouldn't otherwise know how to do. And then we'll be back here on Thursday again. I hope 11:30 is going to work. I'm just going to stick with 11:30 because we got all these meetings that are running 10 to 11 now, and now another one at 11. So stick with Thursday, 11:30, and Friday also at 11:30. And then I do want to tell you that we are required to take spring break. We didn't get spring break the week that you were technically off. So we have to take a spring break. So I'm going to take my spring break next week, and I will be going nowhere. I'll be sitting at home like I'm doing every other week. But all I did was I wanted to make sure, I want to give you things to do so that you don't get a week off, so that you're still technically in school. So if you look on the calendar, and I'll remind you later in the week, there's some extra credit. There are problems from the problem solving chapter. Let me back up. Problems from earlier chapters throughout the year. They're the problem solving page. And I've given you some of those problems like on tests before. They're all listed out one chapter at a time. I just ask you to pick 5 problems. There's usually like 15 or 20 or so on the page. Pick 5 problems and send them to me. I'll give you a little bit of extra credit. That'll be your work for next week. So I'll start 5.5a on Thursday. 5.5b I'll teach you on Friday, and then we're going to be off for a week. And then Monday, Tuesday, when I come back on the 13th and 14th, we'll have some more lessons. So April 2nd, April 3rd, April 13th, April 14th are the 4 remaining lessons I've got planned before we wrap this up towards the end of April. Okay? Any other questions for me? All right, you guys. I miss you. I hate having to do it this way, but at least I get to talk at you a little bit and have some good times, and I'm happy to see your faces again. So be good. Wash your hands. Stay healthy. Stay away from people. And keep in touch if you got questions, okay?
Okay.
Great. Bye.
Bye.
Bye.